Sweet, let's begin. Okay, so this is a really hard problem, and graphing tends to be the hardest for people, so we're going to go over how to graph this one. I would take notes because graphing is the hardest for people. So everybody, this is how you should be thinking of this. First of all, it did not, in my instructions right here, I'm asking you to find the vertical asymptote, x-intercept, and domain. So we only need a rough sketch, but let's kind of pretend like we needed an exact sketch. This is how you would tackle it. You would say, okay, instead of looking at this whole log of the base 3 with all these shifts, let's just look at the parent function log the base 3 of x. Does everybody agree? Yeah. Now, without really using a calculator, we can't figure out what these points are. So instead, let's figure out what the exponential function, what those xy points are, and then can I just swap them to get these xy points? Okay, look, let's plug in a couple values, like I would do about that many values. So we would have 3 to the negative 2, which is 1/9, 1/3, 1, 3, 9. Those are the points for this, though. We want it for the logarithm, so switch them. So we would get 1/9 negative 2, 1/3 negative 1, 1, 0, 3, 1, and then 9, 2. So now, just because I'm kind of trying to get you to be able to think about this without graphing it with exact y points, let's graph this, and then I'll graph the shifts in a minute. So here are the non-shifted log of the base 3 points. So we are going over 1/9 down 2, over 1/3 down 1, over 1 up 0, over 3 up 1, over 9 up 2. So don't we know it looks like this? Rough sketch? Everybody. And then we should draw in our vertical asymptote at 0. All logarithms that are not shifted will have a vertical asymptote at 0. At x equals 0 every time, all logarithms. Unless there's a shift. So now we would say, okay, but there is some shifts here. We got to take this parent function and shift it. So let's determine our shifts. What's weird is the negative 2. So we're going to factor that out, but we can't pull it out. We're just going to factor it out of the terms. So I'm going to pull out negative 2, divide by negative 2, divide by negative 2, then left is x minus 2. I have to have a 1 in front to determine the true shift. Is everybody good? So now we can write in words what our shift is. You would say, right 2. Now this is what's weird. We're used to having the 2 out here in front. It'll work the same way though, interestingly enough. It'll still be a stretch, okay? So it's still a stretch of 2. And then the negative in front of x makes it a reflection over the y. That one is different. So that would be a reflection over the y-axis. Now look, a rough sketch will be easy to make, but also we could actually find the exact xy points if we had to for the test. So you would now take those xy points and we're shifting them stretched by 2. Doesn't that mean you take your y values and times them by 2? That's what vertical stretches do. You take your y values and multiply by 2. Then it says a reflection over the y. So think about it. That would be changing your x's to be opposite, right? Taking those points and reflecting them across y would change the x's to be opposite of what they are. So you would take your x values and times by negative 1. And then we're going right 2. So after you times those by negative 1, then you're going to add 2 to all those values. Then you could write out your new xy points. Does everybody see? I'm not going to do that because I only need a rough sketch. So instead, but if you did, you would do that. So now I'm going to do a rough sketch. Think about it. If I have this function here, I'd say, okay, it was shifted right 2 units. Wouldn't that take the asymptote and shift it right 2 units? So I'd go like this. Okay, that's at 2. And then this is our parent function. It's now stretched up quicker. Good, but that doesn't change anything. And then after that, isn't it reflected over the y-axis? So it's going to be over here. A rough sketch is all I need, because now I can do the vertical asymptote. Is that x equals 2. What's my domain? Negative infinity up to 2, not including 2, because it's approaching the asymptote. It will never, ever cross a vertical asymptote. And then our x-intercept, we need to figure out where it's crossing the x-axis. This is the easy way to do it, which you would not really have known how to do that until this example. So I'm going to show you how to do it. So for all functions, to find the x-intercept, all you have to do is plug in y equals 0. That'll always be true. So we're going to have 0 is equal to log to the base 3 of negative 2x plus 4. So now we need to solve for x, so we know where it crosses. So we need to undo log to the base 3, so what do we base 3 both sides? Base 3 to the 0 is, so 1 is equal to, those cancel out, negative 2x plus 4. And now it's just algebra. So I'd subtract 4. Negative 3 equals negative 2x, therefore x equals 3/2. So our x-intercept is 3/2, 0. Does that make sense? Okay, cool. Remember, last time we learned some properties, some basic properties of logarithms. You should be able to just write down the answer for each of these within 2 seconds of looking at them. Just write down the answer. Sweet. You're right. So base 3 raised to the log base 3 is inverses of each other. They cancel out, we get 10. ln and en do each other, inverses do that, we get 2. That easy, everybody. Moving on. Okay, what I want you to do now is show me on a whiteboard that you know how to switch from exponential form to logarithmic form. So look, there's nothing to solve here. It's already a true statement. I want you to write this in logarithmic form. Then take this log and rewrite it in exponential form. Take this log, write it in exponential form. Take this exponential, write it in log form. Ready, go. Check your answers. If you did this one right, you should have had this. Log to the base 5, and you should get in the really good habit of using parentheses. It just prevents errors. Log to the base 5 of 125 equals 3. Do we need to go through that one? Did you all get it right? Yes, we're all good? Okay, let's re-look at this one. If you were to do this one right, you would write it as 16 raised to the 3/4 power equals 8. That one's checkable. You should know you got it right. Because if you type that into your calculator, it should be a true statement. Otherwise, something went wrong. Any questions on that one? Okay, this next one, we would say, okay, this is e to the 1.386 will equal 4. Did everybody get it right? Which that one's checkable as well. If you type that into your calculator, it should be a true statement. And then on this one, you should check your answer. You should have ln of parentheses 7.3 equals 2. Awesome. Cool. Hey, this is where the lesson for today begins. So recall that log to the base 10 will have this form. Y is equal to log of blank of x. We know that if there's nothing there, it's secretly a 10. We just don't write it. So this is what's called the change of base formula that we're going to learn. And we learn this based on the fact that our calculator, most of our calculators cannot type in anything other than base 10. That's why there's only a log button key. Just log to the base 10. Now, even if your calculator can do this special thing and type in, you have to learn this because the ACT knows that people's calculator can do it for them. So they make sure to write it out and not actually calculate it to see if you know what you're doing. Does that make sense? They'll leave the answer not as a decimal. They'll leave it in its form. So I'll show you what I mean. So everybody, we can literally take and rewrite this in an equal form. It's mathematically equal, and I'll explain why in a minute. So this can literally be rewritten as log in base 10, log of x divided by log of a, which we know that's really log to the base 10 of x divided by log to the base 10 of a. And why is that beneficial? Because right here we could not type it into our calculator unless it was base 10. And let's say it wasn't. Well, then we would rewrite it as base 10 using this change of base formula, and now we can literally type it into our calculator. They are equivalent mathematically. Now also you can take and rewrite this with ln's. It will be the same. So we can literally rewrite this as ln of x divided by ln of a. A lot of people have a hard time remembering which one goes on top. Does this go on top or this? Well, you can see, but when you haven't seen it in a while, people forget. Here's a little trick that helps me remember. So watch, this is a stupid little trick, okay? If I have log to the base 5 of 2, Don't I write the base all mini and small? That's just how we write it. This is a dumb little trick, but it helps me. And this is written bigger. So you will always do log of the big thing, big in size, not number, divided by log of the mini thing. So divided by log of 5. They are equal. That's just how you always hear me say. It's log of the big thing divided by log of the small thing, because a lot of times people forget which one goes on top. Does that make sense? Okay, cool. We'll come back to why that works. So let's look at this. Everybody, last time we learned that if I said to you, what is log of the base 4 of 25? We learned that we could set it equal to x, and then we could go through and rewrite it in its exponential form and try to solve that way. Base 4 and log of the base 4 cancel out, so we have 25 is equal to 4 raised to the x. Now, last time we were able to solve by writing both sides as the same base. Can 25 be rewritten as base 4? No, so there's really no way to solve this by this method. This is one that we can't solve with this method, so we would instead use the change of base formula. So we do log of 25 divided by log of 4. You need to write down the full decimal. Type it into your calculator. Ready, set, go. When you have the full decimal. So log up to the base 4 of 25 is 5? Don't go like this. 9. Yes. Radian. Because this isn't a degree, so what your calculator is doing if you do that is treating that as a degree. Okay, cool. So now look, this really is how you can check your answer. So this should be a true statement. If we type in, so right now type into your calculator 4, and then hit second subtraction, second negative sign, that'll put the last answer you got, so you don't have to retype in that entire decimal. 4 to that entire decimal, hit enter, it should equal 25. That's how you can check, did I kind of do this right? Yeah. Is everybody good with that? You would do base 4. Oh, it is the negative sign, and then you hit second negative sign, and that will put in the answer, the last answer you hit enter on. And then you would hit enter, you get 25. Does everybody get it? Now watch, we could have, instead of using log, we could have used ln of 25 divided by ln of 4. And if you type that into your calculator, you get the same decimal. It doesn't matter if you use ln's or logs. I just always use logs, but it does not matter. Can you guys do this one? Log of the base 2 of 12. Now notice, if you try to solve by exponential, 12 cannot be written as base 2. Therefore, let's just use the change of base formula. Go. I'm ready. 3.5849625 Cool. Check it. So you would do 2 to that answer. 2 to that entire decimal. Does that equal 12? It does. And we could have used ln. We could have done ln of 12 divided by ln of 2, and we get that same decimal. Is everybody good with that? Cool. Now think about it. I did want to point out something interesting. Let's pretend you forgot the change of base formula and you got here and you're like, ah, crap. Can't rewrite those as the same base, so I need to solve this somehow. Couldn't you type this into y1 in your graphing utility where you graph, type this into y2, and then see where the exponential intersects? See where they're equal? Second trace intersect, and you would get, they're intersecting at 3.5, the same decimal. So there's a couple different ways you can do it. Change of base formula is my favorite. Okay, cool. Now, we'll come back to why the change of base formula works once we've learned some more stuff, because it will make more sense. Okay, you do not need to write this part down. You learned this back in secondary math 1. So I'm going to teach you how I teach properties of exponents very quickly. So if I had x squared times x squared divided by x cubed, and if I had x squared raised to the 3rd power, listen to the song I teach. This will help you. When you multiply, you add. When you divide, then you subtract. Raise a power to a power, and you multiply. So everybody, that's a way to help you remember properties of exponents. When you multiply, you can put this together by adding. When you divide, you can put this together by subtracting. You always subtract top from bottom. So that'd be 2 minus 3, which is -1. Is everybody with me? And then raise a power to a power, and you multiply the powers. Okay, now if you remember that song, it's going to help you with these properties of logarithms. Start writing them down or take a picture. So, everyone are you listening, not talking? Properties of logarithms go hand in hand with properties of exponents because they're inverses of each other. So let's look at the product property of logs. If we have log to the base a of u times v, we can, when you multiply u, add. We can split this up with addition. We can do log to the base a of u plus log to the base a of v. And that also works for ln natural log, same property of logs. Now, you're going to have to switch back and forth. And to be honest, mathematically, what's going to be more useful to us is when we have two separated logarithms with the same base. We can, and it's addition in between, we can put that back into one logarithm with multiplication. That's going to be more useful to us. Does that make sense? So when you multiply, you add. So when you add, you multiply. Okay, let's do the quotient property. When you divide, then you subtract. So look, we have log to the base a of u. Since u is on top, it's what's in front. It's positive. Then divide, so we have a subtract, log to the base a of v. And once again, what's going to be more useful to us is going the other way. Taking this and saying, oh, subtract. We can rewrite this as the same log to the base a, but with a division. And then this one's the power property. So it's like raise a power to a power and you multiply it. Kind of have to use your imagination for that one. But if you look at it, this is equivalent to this. So what they're doing is they're taking the exponent and they're multiplying n times log to the base a of u. You see? So if you have this in front, it's multiplied in front. That's actually just an exponent. So we're going to go back and forth between these forms, and we're just going to do tons of practice right now. So you will grab your notes or a whiteboard. Yes. So it's not log of n times log of u. Log of n. No. Nope. Its exponents are different. It's its own property. It's multiplied in front. Yeah. Okay, here we go. So let's look at this one. This one's an interesting instruction. Instructions. So it says, write each in terms of ln of 2 or ln of 3. Now there's no particular reason that we would want it in ln of 2 or 3. This is just testing. Do you know your properties of logarithms? So it's saying instead of having your final answer your final answer can only have ln of 2 or ln of 3. So let's see. This is ln of 6. How can we rewrite that as a 2 and a 3? Yep, ln of 2 times 3. Isn't that equivalent to ln of 6? Well, we got to have it split apart because it says right here, we got to have them as our final answers as ln's of 2s or 3s. When you multiply so this is equivalent to ln of 2 plus ln of 3. And now we've reached our goal because it says write your answer in terms of ln of 2 or 3. Now look. Take your calculator, type in ln of 6, and compare that decimal to ln of 2 plus ln of 3. The decimal should be equal, otherwise you've done something wrong. So now they're the same. So people are saying, well, might be thinking, why did we take this and even do this? There's no reason. It's just they were testing to see if you knew your properties of log. They're equal mathematically. Does everybody understand? Okay, cool. Let's do this one. We have to have our final answer in terms of 2s and 3s. How could we, there's many different ways to rewrite this. Isn't that ln of 2 okay? Isn't 2 what it wants us to have it in, 2s and 3s? So this is ln of 2. How can I rewrite 27 as 2s or in 3s? 3 cubed. I like this idea. So now think about it. When you divide, then you subtract. So this is ln of 2 minus ln of 3 to the third power. Now, as it's written right now, we're really looking at ln of 27, aren't we? So we've got to take and pull that. That's a property of exponent. It's its own property in front, multiplied. So ln of 2 minus 3 ln of 3. This would be in terms of ln of 2 and ln of 3. We're done. Yay. Okay, cool. Hey, let's start doing some, wait, do we have any questions on that? Okay, I'm just curious out there. Grab a whiteboard and see if you can give me these two answers. No calculator. Over it. So everybody, isn't this equivalent to log to the base 5 of 5 to the 1/3 power? Which base 5 and log to the base 5 cancel out. 1/3. Okay, good. Then right here, I'm seeing a lot of people get this one. ln and e cancel out. 6 minus 2, which is 4. Now, I do want to show you how you could have done that one a longer way, but just using properties of properties of logs, just because you might be interested. Watch. We know when we subtract, can't we put this as 1 ln with a division? So this is ln of e to the 6 would be on top since that was positive. And then this would flip it to a division. And now, isn't that ln of e to the 4th? ln and e undo each other and we get 4. Does everybody see? Cool. Awesome. Okay, let's expand the logarithm. So now it says, take this logarithm and expand it out. Write it as separate logarithms. So we know when you multiply, you add. When you divide, then you subtract. Raise the power to a power and you multiply the power in front. So everybody, a lot of people will do this. They'll say, oh, it's 5x cubed. 5 is not connected. Isn't that connected by a multiplication sign? Okay, then you can't group it. So we would split this apart. This would be log the base 4 of 5 plus log the base, I'm going to use parentheses. Let's just get in that habit. Plus log the base 4 of x cubed plus log the base 4 of y. Anywhere there's a multiplication sign, there should be an addition sign. Right? Everybody good? And then yes, we're not done because expanded completely would be all properties taken care of. So this 3's got to come in front. That's what an exponent does, multiplied in front. So then I'm just going to, because I don't want to like rewrite it, scribble that out. So there would be our final answer. That would be expanded all the way down. Are we good? Try one by yourself on a whiteboard or on your notes. I don't care, but on a whiteboard where I can check it better. So I'd rather you do a whiteboard. Expand the logarithm. Okay, so you would say, okay, I'm going to rewrite any radicals with rational exponents. So we technically have this 3x minus 5 to the 1/2 power divided by 7. So only rules that apply are when you multiply, you add. When you divide, then you subtract. Raise the power and you multiply. You cannot split apart a subtraction sign. So this is equivalent to ln of 3x minus 5 to the 1/2. And then because we're dividing, we'll subtract ln of 7. And then our last step would be fix the 1/2. 1/2 ln of 3x minus 5 minus ln of 7. A lot of you got it right. Awesome. Questions? Okay, do this one. Yeah, no, she has to go back. Do this one. Your answers. So you should be doing this. Okay, so we have this log to the base 3 of x squared, because there's a times sign, added to log to the base 3 of y cubed. Now divide is subtract, so minus log to the base 3 of z to the 1/2 power because of the square root. And then, you guys, this is on bottom as well. So you should have a minus here, minus log to the base 3 of p. Then our last step would be to fix our exponent. Now think about this, okay? I'm not going to rewrite it just for a second because a lot of people did this, which was equally correct. Because a lot of people have a hard time, like, well, what the heck? That's 2 divisions. So, like, you know what I mean? It throws people off. But if you think about it like this, couldn't I technically, if I wanted, rewrite this equivalently as pull out a -1, and then we have log to the base 3 of z to the 1/2 plus, right? So we would divide by -1, divide by -1 plus log to the base 3 of p, and then that takes care of it. Because think about it, isn't that putting these multiplied together? Which they are. And then this negative puts them both on bottom. Does that make sense? So you could have left your answer with parentheses. That's why I didn't say no to you guys, because yours was equally as good. So our final answer would be 2 log to the base 3 of x plus 3 log to the base 3 of y minus either parentheses or just distribute the negative minus 1/2 log to the base 3 of z minus log to the base 3 of p. Okay? I got asked this question every hour this entire day. It's such a good question. So I'm going to bring it up. So I just got asked, this is a very valid question. In fact, I used to get confused with this. I remember. So right here, we see 3 log to the base 3. But we just have to be careful because this is 3 times log to the base 3 of y versus base 3 raised to the log base 3 of y. These undo each other, but this isn't an inverse. Does that make sense? This is times times. Which is a valid and great question. Any questions on that, though? Okay, cool. Do another one by yourself. Oh, thanks. I kind of rushed. Okay. Yes. That's one way of writing it. Yes. Okay, watch way number 1. There's 2 ways to do this. There's quicker ways and slower ways, which it does not matter how you get there as long as you get there. So everybody watch way number 1. We could have said, okay, I like to first start out and rewrite any radicals as rational exponents. So we have this x cubed y, and that's raised to the 1/2 power divided by z squared p cubed q. And then because it's a multiplication sign, it's not breaking the forbidden rule to do those raised to the 1/2. So we're looking at this log of x to the 1/2, nope, x to the 3/2, right? Y to the 1/2 divided by that. So now I could do my last step, which is split this apart. So because of the multiplication, we would have, and I'm going to just, does anyone mind if I just go ahead and jump to bringing these out in front? So we would have 3/2 log of x plus 1/2 log of y, and then minus 2 log of z, I got to write below it now, minus 3 log of p minus log of q. That's one way. Second way, watch how much quicker this way is, which it does not matter. If you think about it, this is way number 2. You could go like this. This might help you, though, do it quicker in the future. So we know this is x cubed y to the 1/2, like that, divided by that. So we could go like this. We could go like this. Okay, I'm going to just split this apart with division here. So we have log of x cubed plus log of y, and then isn't that all raised to the 1/2? So then wouldn't this be parentheses 1/2 in front? And then if you think about it, we would then bring the 3 down. So we're dealing with 1/2 parentheses 3 log of x plus log of y. And then we would have minus parentheses 2 log of z plus 3 log of p plus log of q. And they're equal mathematically, aren't they? Yes. I like this way better. Okay, cool. Okay, let's go the other way. Let's see if you can do it. Now, take these separated logarithms and put them back together. That's really where we want it to be at. This is better for us mathematically. Check your answer. This is a 2-step process. That needs to come up. So we have log of the base x of 1/2 plus, that's got to come up, log of x plus 1 to the 3rd. When you add, you multiply. So log of the square root of x times x plus 1 cubed. Did you get it right? Yes. So if this would have been to the 6, no, that's a valid question. I'm trying to think of. So yeah, but then this would be cubed, yes, right, out here, because you're saying I technically could factor out the 1/2, right? I see what you're saying. Yeah, that's kind of a weird one to think about, but yeah. Okay, awesome. Condense the logarithm. Go for it. So we have two separated ln's, so we can put them together using properties of logs as one ln. I would fix the exponents. So we would have ln of x plus 2 squared minus ln of x. When you subtract u, divide. So we have ln of x plus 2 squared, and then the subtract would throw that on bottom. This actually has been seen on an ACT as an answer. So if they said to you, rewrite this on the ACT, they would say, rewrite this logarithm in its equivalent form. Or what is equivalent? A lot of people would choose this option because they remember their properties of logs. They say when you subtract, you divide, but there's only one ln. Does that make sense? That's not how it works. Like to put it together, we can divide, but then there's only one ln there. Cool. Okay, let's not even do this one by yourself. Okay, watch. There are two ways to do this. You could distribute, way number one, you could distribute in a third. So we'd have a third log the base 2 of x plus 1/3 log the base 2 of x plus 1. I'm showing all my work. Now we would take this up there, take this up there. So that would be log the base 2 of x to the 1/3, and then plus log the base 2 of x plus 1 to the 1/3. Now because they're both log to the base 2, we could rewrite this as the same log, so we would have x to the 1/3, and then really times x plus 1 to the 1/3, which is log the base 2 of, hold on, gotta erase this, it's gonna bug. Which is log to the base 2 of the cube root of x times the cube root of x plus 1. Well, if they're both under a cube root, shouldn't I put them under the same cube root? So we have the cube root of x times x plus 1. You see what I'm saying? Okay, way number 2 is quicker, but it doesn't matter how you get there. So we could have said, okay, we have log the base 2 of x plus log the base 2 of x plus 1, and then that was all raised to the 1/3, and now combine the inside. So we have log the base 2 of x times x plus 1, don't we? Like this, raised to the 1/3, and then you would say to yourself, okay, I see why a lot of people then wanted to do the cube root out here, but it's just it goes inside. So we would have this log the base 2 of the cube root of x times x plus 1. And we got there quicker, but it doesn't matter how quick it takes you, as long as you can get there. Questions on that? Okay, condense the logarithm, go. Check your answer. So we have log the base 2 on top, since that's positive is x. On bottom, negative, negative. They both go on bottom. Y z to the 5th. Did you get it? Yeah. Woohoo! Hey, we're almost done. Do this one, more advanced. Hey, this throws people off, but I have a quick question for you. Is 5 minus 3 any different than negative 3 plus 5? But is it different? Not different. So guys, this is a subtraction sign. Like reorder it if you need to. Log to the base 3 of y plus 1/2 log to the base 3 of p, and now minus 3 log to the base 3 of x minus log to the base 3 of z. We can reorder addition and subtraction in any way. So now putting this as one logarithm, we would have log to the base 3 of y is on top, right? Square root of p is on top. On bottom, x cubed and a z. Does then you ended up getting the same answer, right? But you flip it down because there's not an addition sign, so you can flip it straight down. Hey, everybody, this is the last condensing. If you can just do it without any thinking. Just write down the answer now. Well, I mean with thinking, but guess correctly. Yeah. I mean, it's just different examples to help you with the homework. Your answer should be there in 30 seconds. Second. So if you were able to just boom write the answer, you'd say, okay, log the base 2, everything that's positive is going to be on top. You'll have an x, you'll have a fifth root of p, then on bottom, all of that's the square root, so we have the square root of yz. Nice! Okay, I'm putting this up here. It's not just because I like to be up here talking. This is really confusing for a lot of people because they don't know where the instructions are going and where the back of the book answers are going. I literally have more questions on this first, second, and third hour when they started working on homework than I've ever seen. So everybody, it says, simplify using properties of logarithms. So basically what they want you to do is go through and without the use of a calculator, find a final answer without the use of a calculator, okay? So you're going to go all the way down until you get, you've simplified it to be a whole number or a fraction, or if you can't get a whole number or fraction, you'll leave it in a logarithmic form. So let's look at how this would work. So everybody, we have log to the base 2 of 4 squared times 3 to the 4th. So let's reorder this. So let's rewrite this. Log, if we split it apart, it might be easier to simplify. Log to the base 2 of 4 squared plus log to the base 2 of 3 to the 4th. That might be useful because now I can see if I can simplify things using properties of logarithms. Okay, next step. I'm going to take care of the exponents. Does everyone agree? Okay, let's do that. So we would have 2 log to the base 2 of 4 plus 4 log to the base 2 of 3. Now from there you would say, okay, can anything be written? This is what I would check always next. Because we're not allowed to use a calculator, we are not going to use the change of base formula. You see? Because you're not allowed to touch a calculator. So instead you'd say, can I rewrite this or this as base 2 so that things can cancel out? Well, isn't 4 2 to the second power? So let's rewrite this. 2 log to the base 2 of 2 squared plus 4 log to the base 2 of 3. Now, there's nothing we can do here. So now, can't I, there's a couple ways we could do this. Can't I pull this down in front? So times that. So we have 4 log to the base 2 of 2 plus 4 log to the base 2 of 3. So then these cancel out. So our final answer is 4 plus 4 log to the base 2 of 3. And there's nothing more we could do here. We would need to change the base formula. So this is where the back of the book would stop. Because this can't be written as base 2 and it's prime, right? Nothing multiplies. We can't split it apart to be base 2 in any way. Because this is connected by multiplication. What comes first, multiplication or addition? Multiplication, parentheses. Does that make sense? Okay, let's do another one. Yeah. No, yeah. So valid question. This is an answer, and technically, it's a decimal, right? If you wanted to find the decimal, if I said round to the nearest decimal, well, first of all, we could have done it at the beginning. You know what I mean? So that's why, because of the instructions saying use properties of logs, you're not allowed to use a calculator. But if we were going to use a calculator, we could go like this: 4 plus 4 times by change of base formula, log of 3 divided by log of 2. On an ACT, you could see it written like that. Does that make sense? Okay, cool. If it says, well, what it will say is, like, calculate this route, like, calculate all the way. It won't say use properties of logarithms. Okay, here we go. Let's do another one, number 20. So everybody, we have log of 9 divided by 300. This is where I messed up the last few hours. So everybody let me focus with you. So we would say, okay, let's split this apart. Log of 9 minus log of 300. Right?
Yeah.
Now think about it. I'm going to write in a base 10 so I don't mess up. We want to write this with like base 10s if possible, and if not, then we'll see if we can break this apart in better sections. So can we rewrite that as a base 10? No. Okay, let's do that, just because then we can actually simplify it more. 3 squared, does everybody agree? So log the base 10 of 3 squared. So then we would have 2 log the base 10 of 3. I'm not going to write base 10 now. Now that's a lot better than that, because it says use properties of logs. Does that make sense? Okay, now this is where we had issues last hour. So we still have minus. Now keep in mind, our goal is to have base 10s. Is everybody with me? So how can I rewrite 300 as a base 10? By either multiplication or powers or anything. 100 times 3, but that's not base 10. So what do you mean by that? So can't we rewrite this as log the base 10 of, you said do what? 10 to the power 2 times 3. Does everybody see why this is useful? Okay, now let's split this apart. We got to distribute the negative. So we have minus log of the base 10 of 10 squared minus log of the base 10 of 3. I didn't write base 10 on this one, but I will just because I did on all the others. So now let's look at this. What, doesn't this one do this?
Yeah.
So we have minus 2. Now look, 2 log to the base 10 of 3's minus 1 log to the base 10 of 3's is how many log to the base 10 of 3's? 1. So we have log to the base 10 of 3 minus 2. Not bad. We split it apart with addition, but because this is it subtract all that stuff, we would distribute the negative. So really, this is how they would have wrote it in the back of the book, because they don't write base 10. They would have said log of 3 minus 2. Okay, moving on. Try this one by yourself, 22. We're really close to being done here. Okay. Yeah, but they're practice. Because you only have to, there's only 2 in that section, so if I did both of those, you wouldn't even have any in that section to do by yourself. So you should have done ln of 6 minus ln of e squared, which is ln of 6 minus 2, and done. Because we're not allowed to touch a calculator. If we were, we'd just calculate it. Okay, this is the one off of your homework now. 19. This one has been asked the question every single hour. So looking at this, we have log to the base 5 of 1 over 250. We're using properties of logs to rewrite this. So let's see here. I personally, there's so many ways to do this. I personally look at this and say, okay, I have log to the base 5 of, how do you want to look at it? Of 1? Okay, we can do it that way. That's not the way I would have done it. And then what? Minus. Okay, I actually like it. Well, what is log to the base 5 of 1 simplify to be? 0. So that's gone. So now we're just dealing with negative log to the base 5 of 250. Now keep in mind the goal, because people get stuck here. We want to write it as base 5 if possible, so things can cancel out. So 250, is it 5 to the anything power? No. Then think of how you could rewrite this. Log to the base 5 of 25 times 10, am I right? Okay, I like that idea. Which is negative log to the base 5 of, I'm going to go 5 times 5 times 5 times 2. Everyone agree? So then we have negative log to the base 5 of 5 cubed times 2.
Okay.
So now, I'm almost there. I would say say I have negative log to the base 5 of 5 cubed minus, because we got to distribute the negative, don't we? Minus log to the base 5 of 2. So then, our final answer would be negative 3 minus log to the base 5 of 2. Questions? Okay. Okay, I want to quickly show you how the change of base formula works. Okay, just watch why the change of base formula works, because honestly you should be wondering, why does it work? You shouldn't just take people's word for it. In fact, the people who are wondering why are the people who are the engineering minds of the world. If we didn't have people thinking, well, why does this work? Or what, like anything, we're not going to have anybody, like engineering runs the world, first of all. So hopefully some of you are wondering why that works. So I'm just going to show you quickly. Everybody has said it's very interesting, so watch. I told you the change of base formula allows us to write this as log of 25 divided by log of 4. But now we need it, you should be saying, but why? Okay, so, yeah, so I'll show you why we can do it. You get why we'd want to, right? Base 10 is your calculator. Here's why we can do it, so everybody watch. If I start here at y is where we began, y is equal to log of the base 4 of 25, and I wanted to rewrite it as an exponential instead, just try and solve it that way. I could do base 4 both sides, couldn't I? Yeah. So then I would have 4 to the y equals 25, don't I? Now remember, when solving, because we're trying to solve for y, when solving, if you do the same thing to both sides of the equation, all is good as long as you do it to both sides of the equation, right? So I'm going to choose to take log to the base 10 of both sides so that I have it as base 10 for our calculator. So I'm going to log base 10 both sides. Log base 10. So then over here we have log of 4 to the y. Why am I not writing base 10? Because it goes without being said. Equals log of 25. Now don't we know by properties of exponents it would be okay to take that exponent and put it in front? So y log of 4 is going to be equal to log of 25. Last step, to get y alone, divide by log of 4. Just like with a square root, who knows, you know? Cool, right? Hey, that's the end of the lesson. Here are the problems.